Can't make this shit up. Can't it up. Can't make the shit up. No, no, no. Can't make shit up. Can't make shit up.
He has a different email that you don't know.
Yes, right. Back to that. Go into your email and say, yeah. Didn't say what you want.
Not yet. Yeah. Maybe I'll work on that today.
Oh, no, well, when you lose your email, it will be important.
Hey, Tony, how's it going?
Hey.
How are you?
All right, so just us so far? Oh, we
So
go.
far, doing well.
All right. Where's our fearless leader, David?
I didn't see any notes from him this morning. Anyone else?
No, the only thing I noticed is that the earlier OCP call on ADK is rescheduled to the same time. So there's another parallel meeting going set up by.
Oh, interesting. I wonder if he
Right.
just
Yeah.
neglected.
Well, this is the correct one because I went into the OCP calendar.
Oh,
Right.
there's David
This is the
there.
correct one, but the 9 to 10 a.m. call, that ADK call was postponed to 10 to 11 by James Wong. So what I can do is probably drop off quickly and see if people are there. We can bring them on back in here. It's the same, probably the same crowd.
Yeah.
Yeah, mostly. I'll rejoin after checking that meeting out.
There he is. Hey, David.
Morning, everyone. What's happening? I heard you guys talking about calendar or something.
Well, we were missing you. Wondering if you were on the other. Some other people may have dialed into a different call. But all right, Tish, you back?
Yeah, why would I be on another call?
Well, there's two meetings invite. There's the one that was
No,
sent.
Tony. So I'm back through the second meeting. So it looks like the same link was.
Yeah. There's only one link, right?
Yeah, it's
Yeah.
only one link. Yeah, no worries about that. So, but you have to join the other meeting then. You have to leave this one and rejoin the first one.
I did that already. I'm in the second meeting now.
No. What I'm saying is you have to go back to the first one. I'm just kidding.
I know.
Okay. All right. Okay.
I got it.
Yeah. I'm world famous for flat jokes, so I'm anyway. All right. So today is SIPI. Fun stuff, right?
Oh, I thought the invite said 80K in the calendar.
Okay, then you're in the wrong meeting.
No, I opened up the calendar on today.
Yeah.
It says 80K. The invite says 80K.
Yeah, we have to remove those invites, right?
No.
Okay.
No, I'm looking at. Let me
Yeah, I
share
know.
the screen.
I know what you're saying.
Okay.
So what we did was, since the meeting was at 9, and we want to merge the ADK and FDK meeting to the main CDX, the invites were updated to be to 10 a.m. and basically have the same link as the main CDX call, right? So anybody showing up for anything will end up in the same place. Now the okay, so we will probably, so let me ask this question then. What do we want to talk about ADKs?
Michael, you have any questions or issues? Michael Durkin, are you on? Hello? We don't hear you. Michael, are you there?
I see him, but I don't think his audio is connected yet. Actually, I can't tell.
I see a microphone.
Yeah. Actually, since Mark, since you're here, maybe you can give us an update how things are going over at IEEE.
Sure, I can give a quick update. I think at today's meeting, Bunchong, who's here, was also there at that meeting. But so for my quick update, they have a 3D blocks reference manual that is now posted on the IEEE meeting site. And they got the lawyer's approval to post that document, that it's approved by IEEE after they removed some TSMC specific examples at the end of it. So now that the document is posted, the request is for people to review that document, at least the chiplet specification part of it, and before the next meeting in 2 weeks. And then what may happen, this was a question that the leader raised, they may decide to set up what they called tiger teams, which are subsets of the group to cover specific parts of the document and work on approving or modifying or whatever specific parts. They talked about potentially having a tiger team for the chiplet specification part of it, and then a separate tiger team for the 3D stack portion. But there's no decision yet on forming those teams. They may decide instead at next week's meeting, we may decide to just keep everything in the one meeting instead of splitting it that way. And they said that will probably cause things to take a little longer, but that may be a trade-off that is considered fine. So yeah, we'll see on that.
Okay, that's very good.
So there's two, an 80K and a 3D assembly that they're working on actively.
Well, I mean, they're working on the approval of what they describe in the standard, and the description includes a 3D, includes a description of the chiplet specification and a separate description in a different file covering the 3D stack. And then there's yet another type of description that they call their feasibility description, or their feasibility format, which seems
Usability or feasibility?
feasibility,
Oh,
where it includes statements that help them, that help teams that want to do this check the initial feasibility of the the sort of stack and arrangement that they're thinking about building, where it includes power network feasibility as well as thermal feasibility and maybe other things too. I'm not sure.
One thing is the copy that is being uploaded is not a complete V3. And I didn't find any information about tests as I mentioned earlier as well. So in the documents of those 3D blocks V3 uploaded, and there's no section about tests at all. So, but the document is not a complete version.
Mark, can you send a link to the document?
I'm not sure. I'm not sure what I'm allowed to do along those lines. But I mean, since Siemens is, I mean, I know that people from Siemens do participate in.
Yeah.
Like one way.
So I'm there, Tony, and
Yeah.
Siemens,
Oh, right. Pratish was there too.
The DRA is only one for Siemens. That's unfortunate, but
yeah. So
Okay, so
I'll
this
see if
is,
I have access to the document. I'm not a DR indeed, so I'll go and check if I have access to the document.
so this
I think that anybody that signs up to the IEEE group has access to the document.
really?
I guess so. Yeah. So we can share the link.
You have those
You have the
access to this 3D blocks I made already.
I don't know what the link is, but I should have access to it. If I get the link, I can check it out. But I have to
if
go.
you send the link, we can all try it right now and see who has access. I honestly,
Yeah, I'm pasting the link. You should not be able to go in if you don't create your account.
Yeah, did you paste the link in chat? Patrish?
So let me paste the link.
yes. You said you posted the link, Pratish?
I put it in the.
It's not showing in the chat.
Okay, yeah, I see it there in the chat.
To be part of these two Tiger teams / technical committees, subcommittees within the working group. And I believe Siemens will definitely have a presence. We'll decide amongst us who goes there. But Michael, I think you should definitely be part of the technical group focused on chiplet definition, because here is the thing. We have to, step one should be to absorb what 3D blocks definitions today exist already, because a lot of infrastructure tool development has been done. So we can't go and rip everything out. So that has to be put in. Now, of course, there will be a question of backward compatibility tomorrow when we come up with a better definition for parts models, pin definition, and there will be it'll be easier to add new things to it. Expansion is easier than change later on. But for now, it would make sense to absorb what is as is, because a lot of us have been also involved with TSMC through the development of 3D blocks over the last years, right? So
Pratish, are they not supporting backwards compatibility to the
no
standard?
right
or
now, they are, but they're just focused on 3D blocks. So the initial desire / goal would be to accept the basic definitions as it exists today in 3D blocks.
I see.
Yeah, as step one.
So I'm after clicking on the link, and I put in my username and password, and I did get through to the Standards Association, but I have a white, it says, welcome to IEEE SA, and it's a white screen.
Yeah.
So has anybody else tried it?
I have tried it,
I
But
can see the 3D blocks I made.
I believe you have to get permission, because every standard, like you cannot access all the standard, like wherever you are participant, then you can do that. Like, so
I think the program manager have to add you, then only you can
yeah.
access the.
But they've already done that in the first 1 or 2 meetings. They assigned our
No.
names.
there's this IEEE meeting space they set up. And I think you have to sign up for the IEEE meeting space in order to get access to that.
No. So if they add your names, then it should be some email that be sending to your corporate email that asking you to log in or whatever already. If it's not the case, then it's unlikely that your name being added there.
Do you know who the email is from? We can do a search and see if
I know the program manager. Vanessa Lalite is the one who added me to the workspace.
Can you drop the email into the chat?
You mean her email?
Yeah, please.
Yeah.
Oh,
And it's a latte.
Vanessa,
Yeah.
Vanessa. Lalit. Vanessa Lalit.
Well, the only thing I have from Vanessa is meetings that are being set up for the like what we had this morning, the IEEE meeting we had this morning. But I don't have anything beyond that.
Yeah.
So I guess I need to talk to her then, right?
Yeah. But just beware. Maybe it's because your name is not added as a DRA. That's why they trying to restrict the access to the DRA only. The DR or DRAs I can access. I can only access it after my name is being added as a DRA.
Okay.
So Michael, what you can do, because you are in the participant list, and you can just send a mail to Vanessa and Sandeep. Yeah, and because the invitation needs to come from them. Indeed.
Yeah. Okay. We'll do that.
Yeah.
So have you been able to get access to it, Patrish?
I have access to it. Yes.
Okay.
But so far, they have just posted the 3.0 3D blocks reference that we already have internally access to, Michael. And today, what they showed,
So it's the same document?
It's supposed to be the same document, Tony. I haven't. I believe so.
I think it's the same, but with some parts removed that had to do.
The one they were showing today,
Oh,
indeed, that's what I was about to say. Yeah, so they have deleted some sections from it and kept the basic.
Well, then it's not the same document. Do they have a revision and dates on there? I know they haven't been real religious about spec revisions and dates.
No, it's been renamed to specific to the work group share, right? So that's the challenge there. Okay.
Yeah.
But theoretically, I'm just debating it. If it's an IEEE working group in works document, how widely can that be shared within an organization? OCP is a different problem. You know what I can
there is no
here
restriction as far as I know. there is no restriction or anything, like, because you cannot vote and all that. That's why the membership is required. IEEE, there is nothing like whatever he showed that it's a need to know basis or secret or anything. None of that is there in any of the
Okay.
documentation.
Okay, so what I'm doing right now, I'll share my screen, at least just the index portion of the document to get this team
The
oriented
date
towards.
is October.
Sorry, Buncha.
The date is October 31st. Right.
I did not understand. I'm sorry.
The date that Michael asked about the V3, Tony asked about the V3 date is October 31st, 2024.
Yeah. Let's see. So I don't know if it makes sense for me to share the screen and show the index from the document, index table, which just mentions what is looked at right now for inclusion in IEEE and what is kept out of scope. Basically, what they have removed at a high level is really the example that they had with COVOS L. They have taken that example out altogether, but all the language reference is still in there.
Are you able to share your screen? I think we can see what you're.
I'm still debating whether I should or not, but I think it's safe to share the index table.
Yeah, does it say anywhere like secret, confidential, or anything?
Good. It's just a watermark sharing with the IEEE whatever P35,
Yeah,
37 working
that
group.
yeah, no. If document doesn't say that like any other place, that it's okay.
Yeah,
Maybe
it
for
doesn't say that.
sharing, yeah,
Yeah.
maybe for sharing you can just ask like Vanessa or someone. But I think this like sharing as in like sending the files. But here like sharing, I really don't think so. If like anywhere you have to write on the document that need to know or whatever, like all those things. Otherwise, there is no restriction.
All right.
It's open
Yeah.
standard. Yeah.
Yeah. So this is the document, and this is the table of contents I'm showing on the screen. If you can see it. Yeah.
Yeah.
All right. So I'll make it bigger. So basically, syntax convention. The focus right now, the first focus is on 3D blocks core connectivity module adoption. So there we have both the core connectivity aspect of it and the chiplet definition aspect of it. And those two work groups will be formed separately. And people could overlap between the two groups. And it would make sense for actually people to overlap between the two groups. And so all the reference as part of the model of the 3D blocks is included. What they have taken away is the example with the co-cell, which would have been very helpful to kind of, to absorb the data. So that they have removed. Now, I think separately, all of us at organizational level should have access to 3D blocks, this reference v3.o document, right? Those who don't should try to get it through IEEE. Yeah.
Another thing, just an FYI. So I actually the 3D blocks, not this one, the other documents. I did talk to TSMC. They said it's an open standard. You can freely share. Not this one. The slides, 3D reference, that slide come PDF, those ones. Like where it has early chip, the one that I was showing you yesterday, that one 3D blocks, early chip planning, and those documents that can be freely shared because they have already presented it in some this thing conference, and I got from that it's okay to share.
So the one I'm showing now, right? This slide you're referencing?
This I don't remember. This not this one, but this is like an open. They have already presented these things to
I see. So
outside.
let me.
So it's kind of like open, yeah.
So this one, the March 27th, Sandeep just mentioned that it's not confidential because the material he has presented it elsewhere before. So that's what he
Okay.
mentions in the
Okay.
meeting.
Yeah. Okay. So I can probably very quickly flash these slides, right? So in the they have a chiplet definition, interface definition, and connection built upon it. And they include examples of definitions here, how they're doing it right now. So the technical committee that will be formed will just go over this section and vote on it for adoption. And there are a couple of examples included in here. And this is an interposer stacked with 2 top dies. Okay. Yeah. And stack definition. So they talk about orientation, hierarchical support. And yeah, we have to also read through this in more details. Yeah. Yeah, this is the last slide on the probe structure support. So if this is open to share, Tony, I'll send it to you. Or maybe we can create an IEEE group folder for Siemens separately.
Yeah, we should do that.
Yeah.
Yeah, this looks very bare bones, at least.
It is, but yeah, the first focus is to absorb what they have, and what we have done
Yeah.
in JEDEC is beyond what's done, right? So.
Yeah.
So Michael, initially we were talking about the ADK.
Yeah.
So anything you want to discuss here with the team?
Well, I was hoping that you would have we would have got back together again after I gave you the Excel structure, and I think we really need to do that before we take it back to the team. Otherwise, we're going to be pretty. It's going to be pretty lengthy. If we can get just a couple of them into place, then I think we have the basis then on which to work with the team here, and I think it will go pretty quickly. So
yeah, I agree. Yeah,
right. So I will there's obviously we want to move ahead with this sooner rather than later. So
yeah, for the team, basically, Michael is trying to standardize, include the rules, ADK rules specific to substrate and interposer into the. We want to define the structures for that. That's the effort he's talking about.
Yeah. Now what we have to, while we're defining it, we really have to decide which standard do we want to put this into. We don't want to end up with multiple standards. So the format for the rules is provided under the JEP30, and that makes sure that we keep the terminology right and the structure right between the provision of a part model file for a chiplet or for multiple chiplets to the rule file. But describing the rules for example, a spacing between two features. Do we measure it between the edge of the feature, or do we measure it between the center of the feature? Describing that, putting in a picture, and naming all of those rules, putting in a description, that type of guideline document for the rules. Where do you want that to be published? You want it to be part of a JEDIC document that's referenced with the part model, or do you want it to be an IEEE document, or do you want it an OCP document? Where do you want it?
We're talking about ADKs, right?
ADK.
For ADK is Tony, yeah. So we want to
And our ADK really is a superset, or at least the intent is it for it to be a superset of what TSMC is doing. TSMC is focusing on specifically the assembly rules for different components, whereas ours would be a little broader, where it could actually be used to describe the substrate type design rules.
Indeed, Tony.
It does not make sense. I'm sorry.
Indeed, Tony. The challenge is with the IEEE working group in place and the same players in place. Eventually, everything we do in JEDIC, the far-reaching goal is to absorb all of that also within IEEE standard tomorrow.
Say that again.
So whatever from here on, anything we do within JEDIC, through JEDIC, will also hopefully be we will be able to replicate with IEEE 3D blocks working group.
Yeah, but they're separate. I mean, we've agreed that they are separate specs. We haven't agreed we're going to reference those, with the exception of the 3D stack assembly. That is something that was discussed. We have actually not implemented anything in the assembly section of the doc. It's been strictly, and if I'm, correct me if I'm wrong, I think at this point we're only describing the assembly connectivity rules. Is that correct?
Well, just yeah.
In 3D blocks, but here we are going to define the whole layout rule, all the layout rules. Physical DRCs for the substrate.
Right. So let me give you an example. IPC defined the rules for applying to a component in order to create the library part for that component in a printed circuit board design. JEDIC defines the structure in which the footprint is represented, so that it can be interchanged between one tool and another tool. The structure is entirely different to the rules. And they should always be different. They should never be in the same document. The same concept now will apply here, because process technology will change. And when that process technology changes, the spacing that's capable between two features will change. And you don't want to be updating the format of the rule.
And
so,
the types of rules will change as well.
Yeah. Now, so a format like TSMC or like the part model is not the place for putting in the rule definition. The rule definition should be in a separate document. If we try to put them together, it will be it will create too much of an iteration.
I think I agree with that, because this is not a part, right? So
agree.
We're for the sake of CDX, we're considering a part a chiplet.
Yeah.
And I think the broader standard also defines a package part, right? Correct, Michael?
Yeah.
But I mean, we're not actively working on packaged parts. Well, we could, but I mean, we haven't really focused on any of that efforts. I think that's already covered in the standard, so there's probably nothing that we need to really worry about from that perspective. If it's a packaged part, it just looks like any other packaged parts.
Yeah, and that's very well covered.
Yeah. So, so I do agree. I don't think it belongs in the part model. So I think these rule decks is not a part. It's rules. So is there another section or something, another standard in JEDEC where it makes sense to put rules?
Right now, there is no standard for the rules that goes into an advanced package. There's only rules in IPC.
No, I'm not asking for package. Obviously, there's nothing for package because we're just starting. This is a work in progress. But I'm saying, let's say for PCB, is there?
No, that's in IPC. IPC deal with the assembly of components into the printed circuit board. Now, I know that there
What about
was,
yeah? Well, those are kind of placement rules, right? But are there?
it's no, it's fabrication rules, placement rules. It's the whole shebang of anything that goes into a set of design rules from a fabrication or a manufacturing perspective. IPC handle.
And what is that standard called?
IPC 7351 for the 52.
I
IPC.
don't care about the number. Is there a name?
I don't remember what the name is for the fabrication side, but for the assembly side, for the library creation, there is a generic guideline for land pattern design. There's another document for the assembly rules, so I have to go and dig out those for you.
So they do have assembly rules. Okay.
Yeah.
I think, whatever structure is used for that, we could do one of two things. We could just create a total separate standard that's, packaging or advanced packaging, and just have the assembly rules in that. And we could include 3D stack type information if we decide that we are going to create our own standard, and assembly connectivity rules, right? So does it make sense to have a totally separate standard for these, or just have, add an additional branch from the PCB for advanced package?
So I know that
before you answer that, for traditional, say, wire bond packaging and flip chip, are there rules for that in a spec someplace?
I
think there are.
I don't know if that's
So-
in IPC right now.
So
but
Tony, I mean,
I-
yeah, Michael, if you don't mind. So Tony, there are standards definitions in terms of ball outs, bump positionings, not really in terms of the physical implementation of a package, right?
So
it
it's really
comes down to the standard that they're running. So if it's a DDR4 package, a DDR5 package, there's electrical criteria that have to be met. There's ball out definitions that have to be met.
Okay.
A lot of the implementation is, on the end user.
So again, it's really
wait a second, Tony.
PCB.
John, what you said there is part of the JEDEC standards for that specific component and the requirements that's needed to be implemented for that component. So JEDEC does that and does that very well, because that's all stimulated around the functionality of a DDR4.
Correct.
I think what Tony is talking about is not component specific. He's talking process specific. And at process specific level, IPC have put out a request to gather members to deal with advanced package design. I don't know if they have actually started off a team on that, but I can find out for you. And that set of standards that IPC has for printed circuit board assembly is very specific. It doesn't get into any functionality type elements. It's just pure manufacturing and fabrication process based driven. And I think that's what we're trying to do as in ADK. If we go outside that bubble of purely manufacturing and process and start to include component related information, then I think the standard belongs to JEDEC. If it is entirely encompassed within the process, then it could be either JEDEC or it could be IPC.
Well, it's really somewhere in between, because when you're creating a component, you need these rules.
Yes.
You can't,
You
you can't create a rule in a vacuum, right? Because an interposer needs to be compatible, with a substrate and a die. So those are three components, and you need a set of rules that are used to describe the pins on each of those components, as well as the interconnect rules.
So if you're dealing with interconnect from a functionality point of view, as in this Manhattan length of a particular.
No, it's not. When you say functionality, you're talking about nets.
Yeah, in terms of in terms of nets.
No, we're not talking about that. We're talking about the physical rules.
Yeah, well then that's no different than generic process rules and library specific rules for components. So a library specific rule is like a footprint, and a process rule is about how close can I place two components together, for example.
So JEDEC calls this class process rules, right?
IPC calls that class process rule. So IPC typically deal with those.
How is IPC related to JEDEC?
They're two competing standards. Well, they have their own domains, right? IPC is a standards group, and so is JEDEC.
Okay, so are we suggesting we should be doing IPC process rules for these assembly design kits?
Well, I can reach out to the IPC guy who was trying to drive this and see where he stands on it. But it sounds to me like process-related rules should be IPC-driven, and component-related rules should be JEDEC-driven. And this is why now aligning to the part model is so important, because when you take two separate set of files and bring them into your software system, you want everything to be all connecting up seamlessly without having to do any, remapping from one structure to another structure.
Yeah. I mean, that seems to be complicating matters, because you're going to be creating components. So we could, in theory, be have well, we are, I mean, we're going to have different components. We're going to have substrates, we're going to have interposers, and we're going to have die. Those are all components, and there's rules that are required to connect those, as well as there's rules to define the placement and spacing and density, whatever type of rules for the pins on each of those components. And if that's in a totally separate standard, that sounds like a lot of, it doesn't sound like sounds like a pain in the neck to have to manage two different standard bodies to design a package. So
all right, so that's why
I would argue this belongs in JEDEC.
Okay.
Whether it's in the part bottle or a separate standard, but it just seems like we're adding a lot of overhead if we're bringing in now a third organization, right? Because we have IEEE.
Okay, all right, that sounds okay.
Oh, okay. So you mentioned IPC. Did you approach IPC, or is that
no? I have not. I have not.
Okay. Is this something they're considering?
I saw an email from them a while back to try and set up some standards around the advanced package, but I have not heard much about it since, so I don't know how successful they are.
All right. So we
I think
should
I think they were struck.
but
Yeah.
I think we should stay within JEDIC for what we're doing. Does anyone
All right.
disagree with that?
All right, so I will give you another update from a JEDIC side. At the last quarter, JEDIC has said internally to their teams that they want to take all their existing standards for published packages and for published interfaces and start to put that into part model format. So this would mean that as we define the rules for ADK, and if there is a set of ADK related rules that would apply to the implementation of HBMs or DDR4s, JEDIC will take the task to write those rules in the format for the ADKs and make them publicly available. Now, these rules would be standard rules. They're not specific industry process rules, but JEDIC would help to do that.
Well,
so
it's a format for describing different types of rules.
Yeah, but in IPC side, you have not only do you have the format, but you also have here's a standard set of rules that typically people can that matches this type of process. But remember, it's standard from an IPC perspective. It's not specific. And so if you want to take specific, you take that same format and you just change the rule values, and now you have it specific to a global boundaries, for example, or a TSMC boundary.
Yeah, I don't think. All right. So
the good thing to take from it, Tony, is that next quarter we should be presenting at the committee for them to ballot the release of part models for HBM 1, 2, 2E, 3, maybe 3, and 4. We'll also be doing a bunch of other packages. So the process has started now, and there's a number of companies working on getting those part models created. I would hope that within 2 years, all the standards that are within JEDIC would be published in part model format.
All right. So I don't think we need to get bogged down in the details of where this fits into the standard. I think, you know, we trust you to navigate through that and figure out the right place. This group is chartered to, you know, define the structures and you know, we want to have JEDIC compatible formats that JEDIC is consistent with their standards, right?
Okay.
Does anyone disagree?
So Michael,
Does anyone disagree with that?
No, we don't. Tony, we are with you there. So we start with that.
I'm saying anyone on the call disagree with that?
Nope.
Okay, so we are in 100% agreement based on who's here. Okay.
All right. So action for myself and Patrush is that we will get 2 or 3 sample of rules ready, and I want to take that to JEDIC as well. And by the next meeting, we will have a basic platform on which we can start adding more and more rules.
Okay, that sounds like a good plan. Maybe I see that John is still here. Maybe we can talk for a few minutes about SIPI if we cover the ADK topic.
And David, I need to talk to you about the 3D stack. So just we missed putting this into the standard the last time, and you had recommended to us to make a small modification. I need to have a meeting with you to discuss that.
Okay.
So if we don't do it now, we need to schedule a meeting where you'll attend and get that, because I don't want to leave it. I want to get it done within the next 2 to 3 weeks, no more than 3 weeks.
Yeah.
Michael,
Okay.
I did something change? Because I thought that we had previously decided we were using TSMC 3D stack format to describe assemblies. Did something change?
Well, what we did say was, I don't think we were going to not use the TSMC format either. I think it was going to be an option, but based on, I think, 2 pieces of data, two more elements of data, we could have put the 3D stack into the existing CDXML structure. Everything else being the same, it was already there. So you might have 100 pieces of data that's defining everything else. The only thing we were missing was the order of the stack. And it just seems very strange that we would go to a different file to get that piece and go to the part model to get everything else.
I'm not disagreeing with that. But if that's the case, then are we changing our position on this? And if so, let's decide here. Yeah, was everyone in agreement to do that?
Tony, my general thought is that I agree with your statement that CDXML/JEP30 is definitely more comprehensive definition, right? Because apart from the bump map, we are attaching a whole bunch of information about those pins, what they are, right? Test, signal integrity, all kinds of weird stuff, right? That's not directly manufacturing related, right? This is
Yes.
a critical piece for the early planning. As part of the early planning, we would need to be able to define a 3D stack, right? So now the question is, actually, it's two. I have two separate thoughts in my head. Okay, first one is JEP30 and CDXML being a superset, right? As long as we have the important rules from 3D blocks that can describe what's on top of each other, I don't see a exact problem, right? Because we can easily do translation, right? And typically you don't want 2 standards for the same thing. But the question is, right, the comment is, it's not exactly the same thing, right? It covers the same topic, but then one standard is a lot broader and has use across a lot more steps in the design flow than the other one, right? So I think we have a little bit of necessity here that with all the other stuff that we have, we need to be able to maintain that description as well, right? And if we have enough information in JEP30, we can always create a 3D blocks.
Well, that is the plan, where these are bidirectional translators, right?
Yes. Yeah, exactly. So.
And it's non-trivial, David, by the way, to convert 3D blocks to JEDEC is non-trivial for the parts model, but
Yes,
that's a separate discussion.
Right. I am sure that 3D blocks has fringe features that definitely we don't care about in the early planning, right? Maybe fiducials and weird alignments and thermal layers and things like that, right? Which really, if you're planning just how to put things together, you really don't care about what is the actual final manufacturing technology about that, right? So I agree. I'm thinking about the basically cross section of what actually let me say it this way: the subset of information in 3D blocks that is useful for early planning, right? It's one thing when you get to sign off and you have to ship the GDS files to TSMC and you have to tell them how exactly they have to stack them and what stuff they need to use, right? That's a different set of data, but there's definitely a subset of 3D blocks that is going to fit nicely into JEP30. So JEP30 and CDXML can cover that little piece.
What I can also say is that I'm not going to tell you who, but I am going to say that there are companies working with JEDEC who are going to rely on the JEP30 and are saying that they're going to implement the full scope of JEP30, irrespective of what TSMC does with IEEE.
Yeah. Yeah, there's a little bit of, I expect that there's going to be a little bit of pushback and fight, what exactly it is, who controls it and all this stuff, right? So I think the market can decide that if we with all the data we have in JEP30, if we need to add a piece of information to it that is useful to us, I don't see why not.
Yeah.
So one question, one scenario, right? Like suppose 3D blocks has so many parameters, and if actually JEDEC doesn't have it, we just add it into JEDEC so that through translator it goes into the 3D blocks framework. Is that how we are going to do it?
Yeah, I guess.
You would have to if we're going to maintain compatibility.
Correct. Yeah. That's what.
Yeah. I guess the one of the examples I'm thinking of is, for example, left, def, and Verilog.
No,
and
actually, I
right?
believe it was going into further little bit more detail, like alignment marks. Okay, keep out zone, even like lower than that.
Yeah, that's to me a simple stuff, right?
Okay.
So if data that's hosted in TSMC covers, let's say, 20, 30, 40, 50% of what's inside in the part model, then when you do the mapping between the two, you translate whatever data that the recipient system can take. But you cannot transfer data from part model into TSMC if TSMC doesn't support that specific piece of data. And so you lose that
Correct.
type of data.
Yeah. So assumption is that TSMC is subset of JEDEC. That's my assumption.
Yeah.
It's not assumed. Yeah.
Right.
Yeah,
and if you dumb down data into XY coordinates for each individual bump, and you have that inside in a TSMC, then you're trying to rebuild intelligence as you move from TSMC back into JEDEC. And that may, as Patricia said, that's difficult. That is very difficult to do. But going from
so we have to come up with very, very smart algorithms. Think about that problem separately, Michael. How do we create parts model from existing design data, whether it's 3D blocks or whether it's some other left or def representation of the design or GDS?
Yeah.
And that's a very hard problem. Yes.
Yeah. So So if you have, let's say, dumb data in TSMC format and you transfer it and you leave it as dumb data into the part model, that's easy. But if you're trying to intelligize the data, then you have to go through some algorithms to figure that out and and to do that. And so that becomes more and more necessary the bigger and more complex the designs become.
Yeah. One thing that I see even today, there is overlap between JEP30 and 3D blocks, right? Both define bump locations, right? But JEP30 comes and says, "Hey, this is this." No, it's not only this bump, but it's this pin name, and these are the electricals on that, right? And it tells you what the composition is, what materials it is, and so on, right? 3D blocks may or may not tell you that, but at least on the bump location, right? They both have it, but with different data attached to each bump, right? And definitely JEP30 is more comprehensive. So as far as 3D stacking, we have the same situation, right? We want to describe, okay, we have this many chiplets in JEP30. We want to be able to describe how they're put together. We can always do that, right? It's just coordinates that we have to provide. Now, do we have to put all the
It's more than just coordinates.
No, let me finish, right? Now, do we have to put all the alignment marks in JEP30 so that we match 3D blocks and so that the manufacturing guys can understand that? I am not sure about that, right?
You need to define a fiducial, right? Because everything is placed to reference, and that needs to be defined, and different manufacturers will have different mechanisms to do that. So that's probably going to be boundary or manufacturer specific. But the structure, at least, I mean, TSMC doesn't care. Well, I don't know. I can't say that, but TSMC may only care about how they do fiducials. But I think if we're going to be a true open source format, we need to be able to have a user define the fiducial. And if we have three different, die that have coming from three fabs that have three different ways to define those fiducials, we should be able to support that. And then the placement is done with respect to those fiducials. And it's not just the placement, it's also the orientation, flip and rotate, right?
Yeah. It's flip and rotate. Now, what I'm thinking is probably we should divide and conquer this problem, right? If we need the coordinates and flip and rotate, we just put that in JEP30. If somebody
that's
says,
already
hey,
that's already in JEP30, and unless I'm missing something, fiducials, ability to join two different dies together, rotate them, offset them, all that's available. What's not available is putting one die on top of the other die in the stack. That's the only piece that I see that's missing, and that's to me it's just
So
a tiny.
Where is that in the part model?
In the die array structure, you can.
Yeah,
if
but
you
that's for a die array. We're talking about the next level up, where we're dealing.
Then what you do is you create. That's why I wanted to go and create a part model for an assembly based on a floor plan, to be able to show you how you take dies from one part model and another part model and build it into a higher level assembly. But
guys, I'm sorry to interrupt you. We are past the hour, and I need to drop off. So let's take that discussion next time. And, and Michael, maybe we can talk sometime next week.
Yeah, no, let's try and make a plan for next week then, right, David? I send you out a group of sample sets. Okay.
Dave, if you want to talk SIPI between now and next week, or now and a couple weeks from now, just reach out, or I can reach out to you and we can set something up.
Yeah, let's do that. Let's talk offline a little bit about that.
All right,
and
sounds good.
Patrush, will you? My calendar is up to date. So will you?
Yeah, so is mine, Michael. In fact, I am available later this week as well as next week as well.
Okay, so maybe we'll get something started tomorrow, right?
Yeah.
No, let's leave it to next week. I've got enough on my plate this week, so let's leave it to next week.
Yeah, works for me.
All right. Thank you, guys. Bye.